Now I'll show you a few examples of how to do these questions using algebraically and also using the calculator. I'm going to do question 3. I'll try question 3a and also question 3c. So this one is a similar one to the one that example with the negative basis before. So -1 to the power of 5. Now what does this mean? The base number is -1 and the index in this index or the power is 5, which means number 1, -1 is multiplied by itself 5 times, and that looks like this. -1 times -1 times -1 times -1 times -1. Notice that I'm putting bracket around each number, and you don't have to, but this is just the habit. So when you work around with negative numbers, you don't make a mistake of accidentally putting negative number in the wrong place without putting the brackets and making calculation mistake. It's just a habit to get used to. So when you use calculator as well, you make sure that you eliminate this potential error. Now I could do, alright, well, -1 times -1 is a +1, and -1 with -1 is also +1, then we have -1 left. 1 is 1 times -1, so 1 times -1 is -1. We can also use the calculator for this. Actually, I will do question 3c next, and then I will do calculation. So -1 to the power of 14. Now we could do it either the same way as how we did it before with A, but this time what I'm going to do is I'm going to use our green box definition. That's on page 326. According to the green box on page 326, a negative base raised to an even power is a positive. We have a negative base, and we have an even power index. And therefore, we know that 1 times itself is 1, and -1, and just 1 times 1 times 1, it just becomes 1. And therefore, this is going to be +1. As it's 14 as well. Or obviously, we can do all the way 14 times, and then figure out this is 1, this is 1, this is 1. And if we continue to do so, we'll notice that there are 7 pairs of 1. How do I know that? Because there are 14 of it. And if we take 2 each, there's 14 divided by 2, there are 7 pairs. And they're all positive ones. And 1 times 1, 7 times, obviously, is 1. And for this reason, we can know that the answer to C is going to be 1. Now, how do we use the calculator for this? Let's see. As I mentioned before, I'm always going to get into the habit of putting a bracket around the negative base. So I have wrote down -1 to the power of 5, because that was 3a. And the answer is -1, which is exactly what I got. Let me try -1 to the power of 14. And this time the answer will be 1. So we just proved that this is correct. Moving on to question 5. I'm going to do question 5C and question 5D. This question 5 asks us to use your calculator to evaluate the following and comment on your results. So this one actually wants you to talk and communicate mathematically. But this one doesn't have to show any sort of working out. It just wants you to show that you have used a calculator for this. And if you use it into a calculator, you will type in -6 to the power of 2. And this will, on your calculator, if you try, the answer will be 1/36. 1/36, or the calculator might say 1/36 in decimals, it would be 0.027 recurring. If you do D and you put into the calculator of 1/6 squared, or actually you might like to write it like this, because that's the whole denominator, you will also get the same result, recurring. And therefore, what we can tell is that these two values, C and D, are identical. And if you do part A, B, and also E, F, we will notice that we'll find the pattern that, if the index is negative number, for example, -1, -2, or -4, it is equal to converting that negative to a positive number, but putting the whole thing into the denominator over 1. And therefore, if we write that into an equation, a, some base, to the power of -n, some negative number, is equal to 1/a to the power of positive n. Now this is a typical example of one index law. We just happen to find it out through pattern recognition, and we will do more of these in the next chapter. Good luck.